Hello everyone. So SIP, Session Initiation Protocol, is a very common VoIP signaling protocol. It often dominates this discussion. So we will talk about SIP basics and security attacks, including authentication, hijacking, and denial of service. We'll also focus on security attacks against VoIP infrastructure, specifically SIP user agent, registrar, redirect servers, and proxy servers. For more information on SIP, refer to RFC 3261 as indicated in this link. So let's start. We'll start about the basic SIP basics. A typical SIP VoIP solution includes 4 PAR: SIP user agent, registrars, redirect servers, and proxy servers. SIP usually listen on TCP or UDP port 5060, but it can be configured to any port desired. The following is a brief overview of their functions. We have the user agent. A user agent is a soft phone or hard phone with SIP calling capabilities. The user agent can initiate calls and accept calls. We have registrar. The registrar server registers user agents on network and can be also used for authenticating them. We have the redirect server. So the redirect server accepts SIP requests and returns the address that should be connected to complete the initial request in the case of multiple location for SIP user agent. And we have proxy server. The proxy server forward traffic to and from user agents and other locations or devices. Proxy servers may also be involved in routing and authentication. Because VoIP protocols are not very firewall friendly, a proxy server is also often used to centralize VoIP packets on a network. So, the SIP protocol. The SIP protocol is built similarly to the HTTP protocol, both containing different request methods to invoke specific actions. The following is a list of SIP methods from the core protocol and their actions. So, first of all, we have the invite method. The invite method invites a VoIP user agent to a call. An invite request is sent by one user agent to another user agent to initiate a call. Invites travel from the source user agent to any number of registrars, redirect server, and proxy servers, and then on to the destination user agent. We have registrar. The registrar request registers an SIP user agent with a registrar. The registrar request is sent by a user agent to a registrar for the domain, and the registrar server registers all the user agents within a specific domain. It's also used with proxy servers to route calls to and from user agents. And we have ACK, acknowledge. The acknowledge message is sent from one user agent to another in order to confirm receipt of a message. The ACK or acknowledge message is usually the third part of a 3-part process, indicating that the handshake is completed between two user agents and the media portion of the call can begin. Cancel. The cancel method cancels an existing invite message. A user agent can send a cancel request to terminate a previous valid request. We have buy. The buy method hangs up an existing VoIP call or session. The buy method is used to terminate specific session. Option. The options method is used to list the capabilities and supported methods of a user agent or proxy server. As with HTTP, when options is sent from a user agent to a proxy server, the proxy server can respond with a list of methods it supports. Now we'll talk about the structure of the SIP messages. Well, we have SIP message usually contain a few more items, including the following: to field. It's the recipient of the original SIP message. From field, the sender of the SIP message. Contact field, the IP address of the SIP user agent. Call ID field, a number that uniquely identifies a given call between two user agents. All SIP messages that belong to a single communication stream, single phone call, use the same call ID so that the packets will be grouped correctly. Sequence field. Sequence field of SIP messages, a sequence number is a value that shows the order of packets when several packets are sent between entities, and it usually increments by one. Content type field. So the MIME, or the multi-purpose internet mail exchange type for the payload, such as application/SDP, just an example. We have content length. Field content length field is like include the size of the payload in the packet. While SIP provides clear and straightforward methods to communicate from a user agent to a register, redirect server, proxy server, or another user agent, it lacks a method of strong authentication or authorization. This lack of strong security can allow attackers to abuse SIP on a VoIP network. VoIP networks using SIP identify users with identifiers that are no more secure than an email address or web URL. Specifically, SIP URIs, Uniform Resource Identifiers, identify an SIP user agent in the form of SIP, the user domain.com. So now we'll know how to make a phone call using SIP method. Alright, so this is gonna be interesting. Alright, so now that we have briefly covered SIP methods, let's walk through an example of VoIP call using the methods. The following steps highlight a sample VoIP call using SIP. The call involves two users, the user agents Sonia and Kazum, and their required intermediate systems. Figure 2.1 illustrates the step-by-step process. So, step 1, registration. First, SIP user agent Sonia registers with the registrar in its domain om.com, and SIP user agent Kazum registers with the registrar in its domain om.com. If authentication has been enabled, it occurs during the registrar or invite steps invite steps. So the invite request. So now Sonia wishes to make a phone call to Kazum. Sonia user agent send an invite request to the SIP proxy server from Sonia om.com to Kazum om.com. So the proxy server in Sonia's network perform a DNS lookup for om.com. After the lookup is complete and om.com is located, Sonia's proxy server send the invite request to the proxy server in Kazum's network. Step 3. The proxy server in the om.com network performs a lookup for Kazum's location. The SIP registrar responds to the lookup with Kazum's address location. The proxy server in Kazum's network sends a 100 trying message to Sonia to indicate that the invite request has been received but not yet sent to Kazum. Step 4. The proxy server in Kazum's network forward the request to Kazum. Step 5. Kazum's user agent reads the request. Step 6. Kazum's user agent sends a 180 ringing message to Sonia indicating that the remote telephone is ringing. Step 7. Once Kazum answered the phone, her user agent sent a 200 OK to Sonia, assuming she wants to proceed with the phone call. Step 8. After receiving the 200 OK message, Sonia sent an acknowledgement ACK to Kazum, acknowledging that she received the 200 OK message and that they can proceed with the call, the VoIP call. Step 9. RTP, Real-Time Transfer Protocol. Packets are then exchanged on the media layer, not the session layer, okay? It is the media layer, RTP, always on the media layer. So RTP is the protocol that actually transfers the audio media for each phone, but SIP is used to set up the session. Both protocols work together for the entire VoIP session. Step 10. Once the phone call is complete, Sonia can terminate the call by sending a bye message to Kazum. Step 11. Kazum accepts the terminated call and sends an OK message to Sonia. So it's very interesting. How many steps? So okay, now I made like a example for. So this is how they will exchange messages. Okay, you can see the sample of register message from Sonia. Okay, how Sonia register on their register server, and how Kazum register in her register server. We have the invite message, which is sent from Sonia to Kazum, the 100 trying message from the server proxy of Kazum to Sonia, like yes, the server got the invite request. So all this sounds familiar now. After that, okay, after this we'll talk about how to enumerate and register with an SIP user agent. So we have enumeration and registration. Network port scanner can be used to enumerate SIP user agents, registers, proxy servers, and other SIP enabled systems. SIP usually listens on TCP or UDP port 5060. So enumerating SIP devices on a network. We can do that. Okay, here's how to enumerate SIP devices on a network. First of all, okay, download nmap from http insecure.org nmap. Now enter nmap on the command line Windows or shell Unix to retrieve the syntax of the tool. Alright, okay, before entering that command line, okay, normally it will write like enter the following nmap command on the command line, okay, or the shell to enumerate SIP user agent and other intermediate devices. So on the shell you will write nmap, you write nmap.executable exe dash su space dash p 5060 the port and the IP address range. I'll give you an example about that. So or for a class B network address range on 172.16.0.0 network, enter nmap executable, okay, as followed. Right, not before this, we have some other steps. Okay. So each IP address that shows open port for the state as shown in figure 2.2 is probably a SIP device. As you can see in figure 2.2, the addresses 172.16.1.109 and 106 and 70 and 72 172 16.1.109 and 172.16.1.244 are probably SIP devices. So once the SIP devices have been identified on the network, one can attempt to register with them using an SIP user agent. Additionally, because authentication is often established, authentication is often disabled or enabled using weak passwords such as the telephone number of the phone. This process can be rather easy. Okay, we'll discuss breaking authentication later on. Okay, for the to register with IP devices, we'll talk about it later on, because normally you have to download and install the user agent xlit, and all the steps are described within the PDF file. So we'll go now through the authentication process. So on the authentication, SIP uses digit authentication for user validation, which is a challenge response method. The authentication process is largely based on HTTP digit authentication with a few minor tweaks. When user agents submit an SIP register or invite method to a server that requires authentication, 401 or 407 error message is automatically sent by the server, indicating that authentication is required. Within the 401 or 407 response, there will be a challenge nonce. Okay, the nonce is an arbitrary number which use for crypto to crypt. You can check that on Wikipedia. So the challenge is used in the digest authentication process that will eventually be submitted by the user agent. Specifically, the user agent must include the following entities in its response. We have the first one, it's the username used by the SIP user agent, like Sonia. We have the realm, is the associated domain for the session, like we will see later on. And we have the password used by the SIP user agents. We have the method, SIP method used during the session, such as invite and register. And we have the URI, the uniform resource identifier for the user agent, such as SIP point of speech 192.168.2.102. And we have the challenge nonce, the unique challenge provided by the server in the 401 or 407 response. And we have the C nonce, the client nonce. This value is optional unless quality of service information is sent by the server, and usually the value is absent. We have the nonce count. The number of time of client has sent a nonce value. This value is optional and is usually absent.